one day we're going to live and work on the moon, and we need to know, is there any water? Are there any volatiles, any kind of chemicals that we can use for manufacturing? Say we want to build a landing pad. How can we use the lunar soil to do that?
On January 15th, 2025, history was made, albeit quietly, as a spacecraft no bigger than a washing machine prepared to take humanity one step closer to the moon. This isn't just another routine mission. It's Firefly Aerospace's Blue Ghost lander, and it's carrying with it an extraordinary payload of technology and science that could reshape our understanding of the moon. What's inside this small craft? 10 revolutionary experiments designed to answer some of the biggest questions we have about the moon and beyond. With the roar of SpaceX's Falcon 9 rocket, Blue Ghost embarked on an unprecedented journey, soaring into space to carry out a mission that will make its mark on lunar exploration. But this isn't just another one-off mission. Blue Ghost is a stepping stone to the future, a mission that blends cutting-edge technology, scientific innovation, and the drive to push the boundaries of space exploration. Blue Ghost is no ordinary lander. It's part of NASA's Commercial Lunar Payload Services (CLPS) initiative, a groundbreaking program designed to facilitate the delivery of scientific payloads to the moon. And it's not just for scientific glory. This mission is critical for NASA's Artemis program, which plans to return humans to the lunar surface within the next few years. But before astronauts set foot on the moon, Blue Ghost is here to prepare the way. For the next 45 days, Blue Ghost will travel through the void of space, checking in with its systems and conducting important health checks to ensure everything from its communication systems to its scientific instruments is functioning perfectly. During this time, it will carry out some of the most exciting experiments ever performed on the moon. Experiments that could shape the future of human space exploration. Once it reaches the moon, Blue Ghost will go to work. This mission carries 10 of the most advanced scientific payloads ever sent to the lunar surface, each one designed to unravel the mysteries of the moon's environment, and each one could contribute to humanity's long-term goal of living and working on the lunar surface.
The lunar lander was designed for stability. It's about 6.5 feet tall and 11.5 feet wide, so it has a low center of gravity and a wide footprint. Blue Ghost has a robust communication system with 1 X-band antenna and 3 S-band antennas that enable HD video transmission from the lander to Firefly's Mission Operations Center in Texas. The lander has 3 solar panels to help power Blue Ghost and our 10 NASA payloads.
One of the first experiments that will begin is the Next Generation Lunar Retroreflector, NGLR. This isn't your average piece of technology. The NGLR will precisely measure the distance between Earth and the Moon using lasers beamed from Earth, which will bounce back to the lander's reflective surface. With sub-millimeter accuracy, this tool will help scientists chart the exact position of the Moon and improve our understanding of the Earth-Moon system. This could revolutionize the way we navigate the Moon and beyond, potentially enabling more accurate lunar landings for future missions. Now let's focus on one of the biggest challenges we face when working on the Moon, lunar regolith, that fine, abrasive dust that has caused problems since the Apollo missions.
Trying to focus on 2 EDSs, self-cleaning surface, a glass and a thermal radiator. And what's going to happen is when we land, we have 6 other EDSs that their whole job is to lift dust from the surface and direct it and deflect it onto our EDSs.
Hold that up for a second, Dr. Buell, because you can see through those little bands, right? What are those? It looks like that the dirt can pass through them.
Those are just electrodes. The same thing in our transparent EDSs.
They can kick up the regolith onto it? Okay.
The Moon's surface is covered in a blanket of regolith, and it's not just irritating, it's damaging. In fact, Apollo astronauts struggled with the dust that would get into their suits, their equipment, and even into their spacecraft. It's sharp, jagged, and relentless. To combat this, Blue Ghost is deploying the Regolith Adherence Characterization (RAC) experiment, which will study how the Moon's regolith sticks to different materials exposed to the lunar environment. The data from RAC will help scientists understand how regolith interacts with various surfaces over time, whether it's the spacesuit fabric or spacecraft components. This experiment will be vital in designing more durable equipment for future human missions. Beyond understanding regolith, Blue Ghost is also testing a revolutionary technology designed to keep lunar dust at bay. It's called the Electrodynamic Dust Shield, EDES. This system uses an electric field to lift and transport dust particles away from sensitive surfaces. It's a technology that could change everything about how we operate on the moon. Imagine solar panels on the moon that never accumulate dust, windows that stay clear, and spacesuit visors that are always pristine. Thanks to EDS, lunar explorers could finally be free from the persistent and damaging effects of regolith. This could be the technology that makes long-term lunar habitation a reality, allowing astronauts to work and live in the harsh lunar environment without being burdened by the moon's abrasive dust. As Blue Ghost makes its descent to the lunar surface, it will be studying something very unique: the interaction between the rocket exhaust and the moon's regolith. This experiment is called Stereo Cameras for Lunar Plume Surface Studies (SKLPS), and it's designed to capture real-time footage of the dust cloud created by the lander's engines during landing. Understanding how rocket exhaust interacts with the moon's surface is crucial for designing safer, more efficient landers. By studying how dust and regolith are displaced during landing, SKLPS will help us refine landing techniques, ensuring that future lunar landers don't kick up too much dust and create dangerous conditions for future explorers. Blue Ghost is also conducting experiments beyond the moon. One of its most important payloads is the Lunar Environment Heliospheric X-ray Imager, LEX, an ultra-thin machine that retains a relatively small number of cameras so it can be used like a life jacket. This instrument will be the first to capture images of the interaction between solar wind and Earth's magnetosphere, and it could help us better understand space weather, a crucial component in protecting both astronauts and satellite infrastructure. By studying how the solar wind affects both Earth and the Moon, LEXI will provide critical data that will help us predict space weather events like solar storms. These storms can disrupt communications, navigation systems, and even power grids here on Earth. For astronauts traveling to the Moon and Mars, understanding space weather is key to ensuring their safety. Next up is the Radiation Tolerant Computer System, RAD-PC. This technology is designed to protect spacecraft electronics from the harmful radiation present on the Moon, where there's no atmosphere or magnetic field to shield us from solar radiation. Unlike traditional radiation-hardened systems that are bulky and expensive, RAD-PC uses commercial off-the-shelf components, lighter, cheaper, and more efficient, and also better and faster. This innovation will be critical for deep space missions. Whether it's protecting equipment on the Moon or shielding spacecraft on missions to Mars, RAD-PC could serve as the foundation for building reliable, radiation-proof systems that will protect astronauts and their technology. After days of collecting data, Blue Ghost will experience something truly spectacular: a lunar sunset. With its power running low, the lander will capture one final moment before the nightfall. For the first time in history, we will witness a lunar solar eclipse from a spacecraft's perspective. End footnote. As the Earth passes in front of the Sun, Blue Ghost will capture the stunning glow of a lunar sunset. But there's more. Blue Ghost will also witness a phenomenon observed by Apollo astronaut Gene Cernan during his mission to the Moon. As the dust begins to levitate, Blue Ghost will record this spectacular display, an image that has never been captured by a machine before. Blue Ghost's mission was more than just a trip to the Moon. It was the beginning of a new chapter in space exploration. With its groundbreaking science, advanced technology, and innovative approach, this mission is laying the foundation for humanity's return to the lunar surface and beyond. And while Blue Ghost may have powered down, its legacy has only just begun. As we continue to push the boundaries of space exploration, Blue Ghost stands as a testament to what can be achieved through collaboration, innovation, and sheer determination. Its legacy will inspire future generations of scientists, engineers, and explorers to reach for the stars. The journey to the Moon and beyond is just getting started, and we can't wait to see where it will take us. Join us on this incredible journey as we continue to explore the Moon, the stars, and beyond. Don't forget to like, subscribe, and share this video, because the future of space exploration is here, and we're just getting started.